So Etienne and myself are here to talk about customizing build scans. So let's jump straight into things. So my name's Luke Daly. I work on the cloud services that we're going to be talking about here tonight, along with Etienne, and we effectively lead the engineering of that project. And all right, so let's just start off. What is a build scan? Let's create one and get going. So I have here a Gradle build on the command line, and I want to create a build scan for this. First thing I'll need to do actually is just increment this, which I should have done earlier. All right, okay.
There's a bug here, so you have to go back.
Oh, this is, yeah, that's our new language. Yeah. That's the build scan programming language. No, it's not. Okay, so that was a little bit behind the curtain. So, all right, so I want to create a build scan for this build. So what I mean by that is I'm going to run the build as we know and love, Gradle W build, and I'm going to include this extra argument here. So Gradle goes through the motions as per usual, builds everything, and we have this extra bit at the end that's new. So publishing build information, now I have a URL. And this is what we call our build scan. So I can just go ahead and command double click that. Takes me off to gradle.com, and what I'm now looking at is the build scan for this build. So a build scan is effectively a record of this build and all kinds of information that we're going to dig into. But that's the basic gist of it. It's you run a build, you create a scan for that, and you look at it. And we're going to walk through the features of that, and particularly some of the customization features. Okay, so we just created a build scan. What is it? Okay, for the build that we ran it for, it is detailed information about what happened during that build. It's a permanent and shareable URL. This is a very important piece, because without this permanent and shareable URL, all that information I just created about that event that happened, myself running that build, the outcome, things were compiled, tests were run, whatnot, that would have been lost into the ether. But now there is a permanent and shareable record of that. So if I want to communicate with somebody else about that, I can just pass them that link. And I'll show you some examples of that coming forward. So what does it contain? What happened, obviously? Which tasks were run? How long did they take? All kinds of things about what actually happened during the build. Also, what was the environment? Where did it run? What machine? What Java version was it? What were the memory settings? So it's more about what just happened. It's also where did it happen to a large extent. And also a very important part is how does this build fit into the larger context? So I want to know from this build scan what is its state in a source repository. Perhaps it has some kind of relationship to some binary artifact in another repository. We don't really build things in isolation. All the software that we make tends to have relationships to other parts of our infrastructure. So this serves as a record of a particular build, and I can then get to further information from that. Okay. All those things in a bit more detail and actually show you them. I just wanted to give you a high-level overview of what they are. Now, why? Next question. So there are a few different reasons why you would use build scans. A very important and very powerful one is much more efficient debugging, and particularly collaborative debugging. So I don't know about you, but on our team, we've been using this internally for quite a while. And whenever I have some kind of issue locally with a build that I don't quite understand, and I suspect somebody else in the team may be able to help me with that, the first thing I do is, with that scan URL, send them that URL and say, can you have a look at this? I don't send them the instructions, hey, if you do this, change this, run this command, set this up, you'll reproduce this error. So this just happened, here's the error, here's all the details you need to know about it, can you help me with this? Extremely powerful. And we've been using this pattern for quite a while for a subset of our builds. Right, when a CI build fails and you want a colleague to look at it, what do? Send them to the CI build. What do you do for a local build? You don't have that same capability. More efficient optimization. So just by having more information available to you about what's going on in a build, that allows you to spot things that you can potentially optimize, as well as the build scan actually telling you, hey, here is a problem, you should fix this. Just by knowing more about what's going on and turning that black box into a more understood thing, it's extremely powerful. A deeper understanding of your build. So this is slightly different to more efficient optimization in that a key to long-term health of a particular project or build is a deep understanding of what's going on. So if you have a sense of the pulse of your project and how it's evolving over time, what your dependency graph look like, what average execution times, you have a much better sense of that project and you can be much more proactive about fixing things. And a very, very important thing which I've touched on already, new levels of organizational insights. Because unless you have built your own tooling to do this, most teams do not have any real insight into how that build actually acts in the wild. What do developers do with it? What is their experience with it? What kind of functions do they tend to run? What kind of failures do they typically come up against? It's just kind of the Wild West out there and you don't know what's going on. So having that permanent record of all those builds in one place to look at is extremely powerful. Okay, so Gradle Cloud Services. So most people in this room put their hand up before, said they've been using Gradle for quite a while. Gradle Cloud Services is a kind of new aspect to Gradle, something that we effectively launched at this year's Gradle Summit. And the way we think about it and position Gradle Cloud Services is effectively value add for the existing Gradle build tool that you know and love. So the Gradle build tool is still the same, it's still open source, it's still functioning the same way. This is all about making that even better. Network oriented, and by that I mean starting to take Gradle and these builds and build operations happening in isolation and starting to join them together in various ways that we get from networking machines that we all know. Gradle Cloud Services, unlike Gradle Build Tool, is not an open source offering. So it is actually not part of the Gradle code base if you were to go and look at it. However, everything I'm talking about tonight, there is a free tier of access available. So this, while it's not open source, it is something we want all Gradle users to be able to use. And there are varying aspects of that. So that's a very important point, that we see this as not effectively our intention is not that this is an add-on to Gradle that some people use, that this is just such an enriching part of the whole build experience that everybody using Gradle uses Gradle Cloud Services to various degrees. And the first service that we have released and what we're talking about tonight here are build scans. And you'll see more coming online in the future. All right, so that's a bit of a grounding in where we are. Let's dig into some of the features in more detail about a build scan. So these are some of the things we're going to walk through, so let's jump in. All right, so I have another scan here. And I mentioned several times that the shareability of a scan is particularly important. So if I did want to share this scan with somebody, all I have to do is copy this URL, send it to them, they would come into it and see this exact same thing. We have some widgets and things to make that a little bit easier, but it's fundamentally the same thing. The link is the currency. But I may want to be a bit more specific than that. I may want to say, hey, can you please have a look at this failed build, and I want you to focus on the failure section here. This is the part I want you to look at. Or I'm particularly interested in you looking at the time taken in various aspects of the build. Or I may say, well, here's the console output for the build. So whoever ran this build, this is what they saw when they ran it on the command line. So particularly useful to share because there tends to be a lot of useful information in the console log. And I may look at this and think, okay, there is an issue up ahead and I want somebody to have a look at this line. So I can focus on that line, send a person that link saying, can you have a look at this line of the output here? So a really fine-grained addressing of the content in the build scan. So implicit in that is one of the features of a build scan is it captures the console output for you. And we have all these different other sections of information that we capture. I'm going to talk about some of them. A particularly interesting one, I mentioned before that we capture aspects of the environment of the build. So not just what happened, but where was it, different aspects of how it's a kind of executional environment. And there are two sections to this. This here, which we call infrastructure, tells me information like what version of Java did it run with and what type of JDK. I would see something different here if it was OpenJDK, for example. What was the operating system? How many compute cores were available on the machine? What was the maximum memory allocated to the JVM? These kinds of things. And this section here, which we call switches, is detailing how was Gradle configured for this build. So I can see in this case, parallel execution was turned on, it ran with the Gradle daemon, and it also ran with -- continue. So why is this useful? Well, it's useful for a number of reasons. If you get one of these things out of the blue and you don't actually know that context because you're not the person who ran it, it starts to give you more of the pieces of what's going on. But for things like understanding why two builds that are logically the same thing and doing the same work are performing differently. So I have one build that's taking 10 minutes, another build that's taking 5 minutes. They're doing the same amount of work. What's going on? So I can start to come in and see, well, it's a different class of machine. One machine may have had 8 cores, one may have had 4 cores. Perhaps the particular environment is only allocating a too small amount of memory to the JVM, these kinds of things. So these environmental factors do impact builds in various ways. Understanding them is very important. Okay, so another very important feature is the ability to look into the dependencies that were resolved for a particular build. So in this build, this little bar up the top here is telling me a few things about the project. This is just the project I ran the build on and created a scan for. I ran the test task, so on the command line I went Gradle W test. By looking at the dependency section here, so I'm looking at the collapsed version here, it's telling me the six longest configurations to resolve here. So which sets of dependencies took the longest to actually download here. Right, so this can point to a problem. If you're routinely seeing that a particular configuration is taking a long time, perhaps because there's lots of dynamic dependencies, that can point to you as someone, if you can optimize that, you can reduce your build times. So as a general rule, the information we display across the whole scan, the slowest things are first, because that's typically what you care about a lot, what's taking the time. I'll come back to that in more detail in a second. Okay, so the dependencies view. So the dependencies view you can kind of think about as an interactive version of Gradle dependencies, right? So is it everybody, who's run the Gradle dependencies report before? Okay, pretty much everybody, yeah. Okay, so this is effectively the same thing, except it's interactive, which is incredibly useful for larger graphs. So these are all the configurations that were actually resolved as part of this build, and I've dug into a particular project, a particular configuration called compile class path. Here is a root dependency, and I can expand and go and see effectively the transitive graph from the root down. I have some convenience things over here to sort of expand and collapse all. So this is useful if I just want to effectively explore. I don't actually understand much about my graph and I kind of want to find interesting paths and things. But typically, you have a question that you want to ask. So you may want to ask, okay, well, across this project, am I using any of the commons libraries, right? And it's not just across a single project, it's across all the projects in this particular build. So it's just found all the matches for dependencies with the string commons in the name and shown them here. And I can expand this out and see, well, I'm particularly surprised about this guy, commons lang 3. I didn't think it was in the project. Why is it there? I expand it out and I see, well, it's a dependency of this guy. So the view we were seeing before was from the root of the graph down. Now what we're seeing is the search matches path back to the root. And so it's effectively the dependency insight view in Gradle. So you're going to get the best of both here. So, so I can search for anything here. If I want to say, well, Commons codec is what I'm particularly interested in. Okay, I've got 2 instances there. And let's say this was a bigger result set. I said, well, I'm actually interested in 1.10. Then I can match the version as well and find instances of a particular version. And I can also, if you've been following along here, if I want to share this with somebody, I can take that link, paste it to somebody and say, hey, check out this result set. So all the information available here is deeply addressable because its shareability is a key part of it. Another really interesting use for this dependency view is if you're using any kind of dynamic dependencies. So here, this dependency is effectively dynamic. I have 4.15 plus here, and of course we show you, just like the Gradle dependencies report, what did that actually resolve to. So I can see that what was requested a dynamic version, and this was the version that was actually used. And what's particularly useful about this is for every build. If you think about the workflow with the Gradle dependencies report, you run it when you know you have a problem. And typically that is after the fact where something occurred. So you see a CI build just failed. you wonder, I wonder if that got, what version of a particular dependency did that get? Was it different from the previous version? It's kind of hard to work that out, right? You can check it out locally and hope the world hasn't changed from that point. But what you really want is what were the decisions made for that build, right? So that's a very key enabler here. Okay, so that was the dependencies view. The performance section is very important and critical. So we have quite a detailed breakdown of what's going on, or where the time is going in your build. And if you've ever used the Gradle profile report, some of this will look familiar, some of it will be new. This goes above and beyond what's available in the profile report. So this is the kind of standard stuff. What was the total build time? These are some high-level distinctions about what's going on. How long did each of those take, right? Standard profile report stuff. Similarly for project configuration, for each of those projects that were configured, how long did they take? Slowest ones first, of course. There's a little bit of extra information here that you don't see in the profile report, which effectively some of the gaps in the configuration. So this is slightly more accurate than what you see there. And we have plans for taking this much further as well, getting much more fine-grained. Particularly when you have configuration time problems, there's a lot more that we will add here to give you much better insight. Dependency resolution, similarly here, all the dependencies that were resolved, or the configurations as they were, how long did they take? And I can start to do some interesting things in group those via project as well. So instead of seeing a flat list with the slowest across the entire project, start to group them by project and start to understand the cost of each project as well. That may be a way that you want to reason about things. And also, this is something new that you do not get in the profile report, is out of the time spent resolving dependencies, how much was spent during the project configuration time and the task execution time. Now this should always be 0 if you've done any Gradle optimization in your time. Ideally, sometimes it's not possible, but that's what you want to do. So it's a very key number to look at to try and get that as low as possible. That's something that you get here. Task execution. Usually the dominator in a build, things taking time. So what we have here is the total time spent executing tasks. This is wall clock time. From the time I started executing the first task to the time I finished executing the last task, how long elapsed. This number is effectively that flattened for a parallel execution. So in this build I ran it in parallel, so multiple tasks were happening at the same time. This is effectively telling me if I didn't run it in parallel, how long would it have taken? That's what we call the cumulative time. So I saved a good minute or so here, just slightly less than a minute. Does that make sense? That distinction make sense? Yeah, okay. So the total number of tasks, something else interesting to know, how many tasks were in this build, how many of them were skipped, how many of them didn't execute for some reason, how many of them were already up to date, in this case a lot, because I had just run this previously, and how many actually executed. Also kind of a good indicator of the incrementalness of your build. If you're expecting a high number there and you're getting a low one, it might point to some misconfiguration, and a breakdown of the tasks in your build here as you would expect. And of course I can group them by project as well, so I can then do a similar kind of thing, start to reason about cost in terms of project as well. Something else that's new, some insight into what's going on with the Gradle daemon. So if you're not using the Gradle daemon, you should be, and you don't really have a choice anymore after Gradle 3.0, so you probably are, if you don't know you are. So what this is telling me, 3 things. How old is this daemon? How long has it been running for? This is important for a number of reasons. If this is a low number, then that tells me that I can expect slightly less performance because things haven't jittered up. Right? The daemon isn't fully warm, its caches aren't full, etc. So this could tell me if I'm comparing the performance of 2 builds, this is a number I want to look at. It's an indicator of why the performance is as it is. Similarly, this is another aspect of the same thing. How many builds has this daemon run before? Just quickly, the inverse is also true. If you see an extremely high number here and you see bad, poor build performance, that can also tell you something interesting as well. And this is effectively an indicator, particularly interesting on CI. So at the time this build was running, how many other daemons were also doing work? It's a kind of indicator of what load is the machine under. And it can also be an indicator of some daemon tuning settings not being quite right and there being too many daemons, that kind of thing. And lastly, we have some sort of proactive settings and suggestions that we look for about the build to try and give you a hint on what you could do to make things better. So it's just saying that daemon was on. If it wasn't on, it would say, here's a link to the daemon, go find out more about it, parallel execution, etc. There's some other things here about pointing out where dependency resolution happened during configuration time and those kinds of things that you might want to look at. So in this case, I get 3 green circles, as would hope, after working with Gradle for 5 years. So, all right, so one other section I want to show before moving on to the custom data side of things is a test view. Incredibly important. I don't know about you, but I spend most of my time fighting problems day to day, fixing tests. So having build scans help me with that is incredibly useful. So we have this dedicated test section. All the tests that have run by the Gradle test task show up here. We show the failed tests first and then ordered by how long they took. So if I want to go and have a look at this particular test that failed, I can just go and click it, and I see the output from the test, any console output generated, plus the exception message, the failure here. And of course, there's a dedicated link for this information, so if I want somebody to have a look at this test, I grab the link, send it to them and say, hey, can you fix this, please? I can also see detailed stack trace information if I really want to. My test framework in this case has chopped this stack trace for me, but if you're using JUnit or something like that, you'll see a very long stack trace here. So do some other interesting things with tests. So here is a kind of a more complete view. So I just see, just show me the failed test for this build. I can say, show me all of the tests. Here there's 1,189 listed by slowest first. So I can, if I want to optimize the time taken here, I can choose which builds to go and look at. I can also organize that hierarchically as well. So I can start to see things by package as well. I've got the browser windows off to the right and I can't quite bring it back in. The time's over there. So I can start to look at things and say, what is the slowest package? What is the slowest class? That kind of thing, explore it in a kind of tree view. All right, so that's an overview of some of the features in a build scan. There's more there, and we're going to talk about a particular section that I didn't go into in a bit more detail, which is about customizing what you have. And with that, I'd like to ask Etienne to come back up.
So what we've seen so far is what the build scan plugin captures for every build. Tests, projects, tasks, dependencies, and so on. But it doesn't stop there. I'm sure everybody in this room would have additional data that they would like to capture as part of their build. And that's where custom data comes into play. So what you can do is you can capture tags, links, and values. And what you capture is basically up to you. And I'm going to go through the mechanics as well as give you concrete examples of that. So let's jump right into the demo from here. Okay, just need a moment to set up. Okay, so I've opened the sample project that we just saw in IDEA, so make it a bit more convenient. Before we look into the actual custom data, I'm going to use the publish always. That's an option that if you specified, every scan that every build you run will publish a scan. So you don't have to do the -d scan anymore. And so whether you run it locally, if I check it in like that, whether you run it locally or you run it on CI, every developer, every CI that runs a Gradle build will publish a scan. And if you think about that, that's pretty revolutionary because for the first time, I would say ever, as an organization, you can start to understand how your build is being used. How does it perform? How are developers using it? What is happening on CI when the build is run? Because all these scans are published to one place, and then you can start reasoning about them. You can compare local builds to CI builds. You compare within local builds. You can compare between regions, and so on. Okay, so when I run the build afterwards, I don't have to use the -d scan anymore. That's the point here. So let's add some tags, links, and values, just so we can go through the mechanics. So I'm going to add a tag, and I'm going to say local, because I want to tag this build as a local build, because I'm running it locally, obviously. I'm also going to add a link. I'm going to call it home, and I'm going to specify some URL. And I'm also going to add a custom value. And I'm just going to say, as an example here, I'm going to give some context and say, well, this is a demo build, basically. Right? What I use for names is totally up to me. What I use for values as well. Okay, so now let's go to command line, and I'm going to run a build. It's publishing a scan, as usual. And now let's see what happened to those values that I captured. What you can see here, up here, is this tag. So all the tags that you specify show up in this upper layer here in the scan. We also see the link. So this is the home link. That's what I called it. That's what you see. I click there, and it shows me that link. I also have a new tab here called Custom Values, because I have custom values. And here I see my key value pairs, basically. Right. Now, the other way to specify those values is I can do that via the command line, or any other means that through which I can inject system properties. So I can say -d scan link, let's say tag, and I just call it experimental. And if I run the build like that, again, I'm going over my phone right now because I don't have a network connection, so it takes a moment to always come up. Right. So what you see now is I have a tag here called experimental. Right. And that is an interesting option because if you're like on a CI machine, you might want to inject more values, right? Rather than the build collecting the information from environment variables. Or you might have a combination, of course, of those. Right. Okay. So back to the build. I added some tags, some links, some values in the build, but I can also do it from the command line. Now let's take a look at some more examples, and hopefully they serve as some inspiration of what else you could do with those basically quite simple mechanisms. So I'm going to take those away, tags and links, and I'm going to apply the checkstyle plugin because I want to show you some things around warnings, and I'm going to enable a custom script that I created with the samples that I want to go through. Otherwise, it would be a bit too much to type. Okay, so first example here is I want to detect if I'm local or on CI, because that's a pretty interesting criteria also when you start collecting or filtering out builds, as we will see a bit later. So I can access system variable, system properties or environment variables. That's what I'm doing here. And if I'm on CI and I expect that variable, then I will set the tag called CI and the link to that CI server. Otherwise, I'm just saying local. Okay, and which is interesting if you think about it. If I'm running on CI and I'm creating a scan, I have the scan. I can now go back to CI if I ever need to from the scan. I can also collect the git commit ID, which is what I do here. Right? And I add it as a value, saying git commit ID. And I'm also constructing a GitHub ID, GitHub link that points me to the revision that this corresponds to. I can also collect the git branch name as another example, and add another custom value for the git branch name. And we'll see how that looks in the UI in a second. Another one that might be interesting is, did I have some local changes? Right? Because if I have a problem locally, but not on CI, and I want to understand, well, why is it working on CI but not locally? Knowing the local differences when I share it with somebody else is very interesting. So that people that look at it, at my scan, understand, oh, okay, this guy had local changes. Or didn't. Right? That's why we also have a tag dirty. Right? Which is also very interesting, because if you have let's say you filter for all the scans that are dirty, you can start to understand how many builds are even run when you have local changes. Do people even run local builds? Yeah. Right. Because if you don't find any, basically means people make local changes and they just check them in. And the last example, let's say you wanted to see the diff between what you have locally and what is the commit that is available remotely. We don't have to go through each line of code, but basically what I'm doing here is I'm creating a gist that contains the diff. That's it. And I'm going to show you that in a second. Another one is code rules that you might apply to your project, and you want to collect them and see them on the build scan. So here I'm doing it as an example for check style. And those are familiar with Gradle know you have all those hooks. So you can say for each task that finishes that is of type check style and that failed, I'm going to go into the report, the XML report, and collect the data that I need, and I'm going to add a custom value for each one down here. Right. So basically, you can see here, I'm getting the file, I'm getting the line, the column, the message, and I put this all together and add a custom value. You could do this with lint, you could do this with findbox, codenarcs, or whatever internal code checking tools you have. Right. Another one we have here as an example is, let's say you want to have a build scan where you have a link that automatically takes you to an issue tracker and creates an issue when you click on that link. Right. Because maybe you have a failed build, that's what I have here. Only if there's a failure, I'm automatically adding this link. Right. So if my result, when the build has finished, there is a failure, I'm checking if there's an exception that I can do something with, and then I'm creating, basically in the end, I'm creating a link, a custom link. So we'll see that in action as well. So these are some examples what you could do with custom values. So let's run the build. I don't need to use the -d scan. There were some failures, check style errors. And now I don't even want to go to that report that checkstyle created on the command line, created locally. I'm just going to jump right to the build scan. Because if I have an issue and I cannot resolve it locally, that's what I would share with other people, and they can look at it. Okay. So let me go here. And you can now see dirty, because I have local changes, so it added a tag for that. I can search for that. Also marked it as local. I can say, I want to create a topic. I want to create a new topic in the form because the build failed, so I got automatic that link. And I'm right here. Right. And whether that's Jira or whatever, that doesn't matter. Right. Okay. I also have the source here that when I go to, gives me the corresponding version that is in version control. And I also wanted to show you the diff, but I had an exception up there because my token just got deleted. There's something weird going on. Okay, and then we also have the custom values. And here you can see all those check style issues that I had are now listed as custom values. So I don't even need to go to that ugly report anymore that I get from check style. I can see right here, and everybody else that sees the scan can see those issues. I also see my context that I had before. I see the Git branch name, the Git commit ID, and whatever else you want to collect that is important for your environment. Right? And it doesn't have to be Git, of course. You could still be on CVS. Then you would have at least one modern piece here. Now, you can see here that I can also search for those custom values. Right? Because if you think about, let's say you collect custom values for each task, because something specific to each task, and you might run a full build with thousands of tasks, you're going to have a lot of custom values here. And being able to search for them will then, of course, be very useful. So, for example, I can say, I hopefully don't have thousands of check style errors, but if I had, I could just easily filter for them, or for anything else. And if you have a bit of a smart naming convention, you can, with this kind of filtering, you can get quite far. Okay. So that's basically what I wanted to show about those different ways to customize a build scan, or add custom data is probably the better term. I can now add tasks, I can add links, and I add custom values. What you put in there is totally up to you, and hopefully this gives you some idea of what you could do. Now, some of the things you saw, you probably think, well, why isn't this part of build scans? And pretty surely some of that will become part of the build scan plugin, that we capture this by default. But until we do this, you can capture it yourself. You're not blocked. And some things will be so exotic or so specific to your build, to your environment, that we will never capture it. It would not make sense. But also then, you can capture it yourself. So you're not limited in that way neither. So to recap what I showed you, you can either do it programmatically. It can be a fixed value that doesn't change with each build, or it can be a value that changes with each build. It's up to you. Oops. Or you can specify it via system properties on the command line or in a Gradle properties file and so on. Now, there are a few more options about what you can do with the build scan plugin and how it manifests in the UI, and not only related to custom values, but also to custom values. And you can find all this in the user guide, so or user manual. Sorry. So here is everything's described that you can configure about the build scan plugin. Now, before we look at the next big picture, I talked about filtering and sorting, etc. One more thing, CI integrations. You don't have to do anything specifically to run your builds with BuildScan enabled from within a CI server, but we have two integrations that make it a bit nicer. So one is for Jenkins. So if you run a Gradle build and you have the Gradle plugin enabled in Jenkins, each time you run such a build and it creates a build scan, you will see that little link here with the elephant, which means from CI you can directly go to the build scan. Right. And as I showed you, you can add a link from the build scan to the CI, which means you now have like in both directions you can go. Same for Team City. We have a plugin. And so really our goal is that when you run a build, you don't even look at what the build tells you or what CI tells you. You go directly to the build scan, which makes sense because we can have a much deeper understanding and visualization of what happened in the build than a CI tool that is just generically running something in the end, right? So whether it's about tests or performance, you don't want to look at CI anymore. You just want to go to this build scan. So we have it integrated nicely that you can just see the build, takes you directly to the build scan. Okay, and so with that said, there's also something called Gradle Enterprise that adds more features and some other stuff that Luke is going to cover here.
So far we've been creating build scans and publishing them to Gradle.com, which is, I mentioned at the start, is effectively the free tier of Gradle Cloud Services. Gradle Enterprise is effectively all of that in a shrink wrap package, as much as things are shrink wrapped these days, that you can install behind your firewall. Right, so it's no longer a central cloud service, it's on your machines, private data, all of the things that come with that. It also has additional features. I'm going to show one of them in just a second. Easy install and administration, simple package to get up and going, provides the kind of standard admin tools and monitoring insight you would need to do to run this as a production service. So basically everything that we're seeing today, you can run within your organizational walls and get all those features and more. If you'd like to know more about that, gradle.com/enterprise is the place to go. And you can, via that page, get in touch with us, and if you want to trial it out, we'll help you out with that. Okay, so the extra feature that I want to talk about is the scan listing. So far we've been looking at individual scans. We're running a build, looking at the scan for that build. But of course you want to start to see all of your scans over time, and this is what this shows you. So all of your builds in one place, local and CI as we've said, search and filter capabilities, you can have save searches, and importantly you can search on that custom data that we've been specifying so far. So here's what we call the scan list. So this is one of our internal instances at Gradle where we've got Gradle builds running through this. So this is our CI and our local builds. And by default, what I'm seeing is effectively all the builds that have happened recently, right? So I can start to filter this down. I can say just show me the failed builds. That's what I'm interested in. If I have multiple projects that I build, I can say just show me the Gradle projects, for example. I can select a time window. I'm only interested in builds in the last 6 hours. All the kind of things you would expect there. And if I'm interested in saying, well, I only want to look at CI builds, I can search for anything tagged with CI or local or dirty, that kind of thing. If I want to, if we have set up to record a custom value git branch name, being the branch, if I say I only want to look at the builds for the release branch, I can specify that criteria as well. And if I perform a search, then any of these I can just go and click on and have a look and get more information about that particular build. So it's a way of looking at all the scans in the system, filtering them, searching through them, etc. And another really important part of this is that the URL for these searches is effectively sticky. So I can set up a bunch of criteria, which would look something like, not that. So show me all the failed builds in the last 6 hours. The URL for this page now, if I would hit apply, would effectively include that. So I now have a permanent link to show me all the failed builds for the last 6 hours, whatever criteria I want to add there. That's quite a useful thing to, at the first time, when you come in the morning, have a look at yesterday's failed local builds, do some error analysis, that kind of thing. All right, so that was the scan listing feature. I'm moving forward for the sake of time here. So all the builds in one place, local and CI, however you want to cut them, use custom attributes to be able to carve things up however you want to, by release cycles, feature branches, whatever it is. Okay, what's next for Gradle Cloud Services and build scans? So more and more details and insights, more and more information into what's going on inside a build. One that we're very excited about is a more timeline-oriented visualization of what's going on, particularly useful for understanding parallelization, utilization, and those kinds of things. A data export API, if you want to take this information and put it into some other external system, some dedicated analysis tool or something like that, whatever it is, it's your data, you can use it. Trends and analytics, so for this particular set of builds, we're getting slower over time, faster. These kinds of things are what you can expect in the direction we're going. And of course, much, much more. So you can start using build scans today. Create some scans, share them, and tell us what you think. We'd love to hear your feedback and your feature ideas and what worked for you, what didn't work for you, etc. And before I jump to that, just want to point out that we are hiring. So if you're interested in joining our effort building this or working on Gradle Build Tool, gradle.com/careers is the place to go for that. So if you would like to get started with build scans and create some build scans for your projects, gradle.com is the place to go. If the distinction is not clear, it's different to gradle.org, which you may used to be going to for all things build tool related. This is a new site right now focused on build scans. Go there, it'll walk you through everything we've gone through tonight plus more. There's some example scans you can look at. There are some dedicated videos walking through some of the features we've gone through plus more. And of course, more on Gradle Enterprise. So that's it. Thank you very much for your time. Any questions before we wrap up? Stepan at the microphone. Yes. So Stepan's question was, would it be possible to do more detailed analysis? So the example he gave, would I be able to find all builds where a particular task took a certain amount of time or was over a certain threshold? And the answer fundamentally is yes, in terms of course, we have that information. That's part of what is captured. And it just is a matter of surfacing the tools to be able to specify those kinds of queries. So today, the search interface is effectively what we showed. So that's not something that you can particularly search for. An option would be to export the data into another system with more fine-grained search abilities. That's what some people are doing. But those particular use cases like that are things we absolutely want to support over time, and really fine-grained questions and interesting insights. Absolutely. Yeah, because there's just an absolute treasure trove of information in there waiting to be found. Yeah. Cool. Any other questions? Yes? A few things, yeah. So the question was wanting to understand what developers are doing with more detail, specifically to try and help them out, right? How are they struggling? Yeah. So a couple of things. So one example of the kind of things that we talk about doing and think a lot about effectively triage of issues, right? So if I can see that over time, no matter what it is, so compilation errors are increasing or particular subsets of tests are failing or let's say test infrastructure relies on some external piece that is flaky and that's causing issues. So being able to somehow identify that as classify that as a type of failure, see rates of those things increasing over time, which effectively becomes ways of doing that classification and surfacing that as well. You can get quite far with this, and this is something we do in our own builds. We do a certain amount of classification via these custom values. So we inspect errors that happen at the end of the build and say, okay, this is this kind of error. And then via the tools we have today, show me all the builds in the last 24 hours with this kind of error. So it's a way of doing that, and it's definitely the direction that we're heading, right? In terms of understanding trends and what's actually happening out there to whatever extent, yeah. Any other questions? All right, well, thank you for staying on. I understand we went a little bit long, but hopefully you enjoyed it, and yeah, thank you for coming.